how do we know this is pyruvate? Because 2 times 3 is 6, right? We don't want to lose any molecules, guys. So at this step of glycolysis, we yield 2 ATP and 2 NADH, right?
Right.
Right. Okay, now we go down, all right? So we also yield 2 NADH from our conversion of pyruvate to acetyl-CoA, right? So we go to the Krebs cycle. The Krebs cycle gives us 4 carbon dioxide. So now we have glucose and carbon dioxide, right? Okay, glucose to CO2, glucose to CO2. We're done with glucose now. Okay? Glucose has given us all of our energy that we need at this point. So we have that ATP, NADH, NADH, right? Right? Go through the Krebs cycle. Then go down. We get 6 NADH from the actual Krebs cycle and 2 FADH2, right? So total glucose is gone. We have 2 plus 2 plus 6 is 10. 2 is 10, or 2 is, sorry, 2 FADH is 2. 2 is 2, that's fine. We have 2 ATP plus 2 ATP, 4 ATP, right? So we're at that point. Now we go out of our mitochondria, the inner mitochondria, and we go to the membrane, okay? So the mitochondrial membrane now, for the electron transfer chain, okay? So, here a proton gradient is made. Protons and hydrogen ions are the what? The same thing, right? Because a hydrogen ion is going to be hydrogen with how many neutrons and protons? One what? Proton, 1 electron, 0 neutrons, right? So if we take out one of those electrons, we just get a proton left. So our hydrogen atom, when it's ionized, it's essentially just going to be a proton, right? So we have a proton gradient that's created in our electron transfer chain. And again, how is that created? By pumping out your H plus ions, right? You know earlier when we said we pumped out our H plus, that is what that does, okay? So we have a proton gradient now, okay? In the inner mitochondrial membrane. Right, your mitochondria is a pretty complicated thing, but you have different folds in it and different membranes, and that's going to be your inner mitochondrial membrane, okay? ATP synthase is going to be what? Someone have a hazard to guess for that? What is it?
It's a it's part of active transport, right? Or it's like a protein.
It's a protein, basically.
Okay.
Right?
Yeah.
It's gonna be. It will literally synthesize ATP. Whenever you says something synthase, it's usually gonna synthesize that thing, or have that thing come in and synthesize something else, right? So here we're literally synthesizing ATP. Okay. So that uses a proton gradient to make your ATP. All right. So we also knew that we have. So we knew that we have 3 ATP per NADH, right? And we have 2 ATP per FADH2, right? So 3 times 10 is going to be 30. 2 times 2 is going to be 4. Plus the 4 we already had gives 38, right? That's how that kind of works out. So is that a little more clear? Do you have any questions, guys? Yeah.
Coenzyme A, like what does it do?
What?
Coenzyme A. Coenzyme A.
What about it?
What does it do? Like
It basically converts your pyruvate into something more manageable, okay? So it's gonna, so you have CoA and acetic acid thing. Yeah. And it's like acetyl-CoA. And so coenzyme A is basically gonna make it more manageable to go into the Krebs cycle to yield your carbon dioxide.
so it's basically just acting as an enzyme.
Yeah.
Okay, so why is it
So a coenzyme is something that's literally going to help another enzyme. So coenzyme is helping something, another enzyme that's helping this process.
Okay.
You can figure out where you get microphone.
No.
Okay, also not to be like,
Yeah.
talk louder,
Tell that.
because there's a lot of chatter on the background.
Okay. So, oxidative metabolism is going to be what our aerobic respiration is going to be called, okay? So, this is in the presence of oxygen. All this that we did is with oxygen, right? We had 38 total, and the net is 36, right? Okay. Pyruvate is oxidized down to the carbon dioxide in the Krebs cycle, right? NADH and FADH2 create a pH gradient by pumping H plus into the mitochondria, and they drive ATV synthase. Or,
How do you write that down?
okay, so are we all clear on the numbers and how we got them and stuff? Everyone good? Kind of? Okay? It's alright. This will become more clear later on. It's a really complicated concept, so having background knowledge in period biology does help. Yeah.
Would it be possible that we could know what the NADH and FADH, what is the FAD and the NAD stand for?
Okay, so I honestly don't know what they stand for exactly. I just know they're abbreviations for longer molecule names. You can look it up if you want, but it's not going to be as relevant because they never really test over what it actually means, right? For our purposes, it's just going to be an intermediary energy carrier, electron carrier, right? Yeah. So, but yeah, good question. Except I didn't know the answer, so. All right, so that was cellular respiration.